This is how to calculate the pH of a solution when you know the molarity and the Ka value for it. The same thing would work for a base, the same procedure. Okay, so the first thing that you should remember is that the formula for Ka equals the H plus concentration, okay, times the anion concentration divided by the solution concentration. Alright, and if you look at this formula right here, you're trying to find pH. They give you the solution concentration and they give you the Ka. But what you should remember is that you can get H plus by, or you can get pH by using H plus, because pH is equal to a negative log of the H plus. So if you could find H plus from this equation, you could plug it in over here in this equation and get the pH. So first thing that you should realize is that you know Ka, you know the solution molarity, and if you remember, you can simplify this formula by writing it like this, that Ka is equal to H plus, but since H plus, the concentration of H plus is always the same as the anion concentration, you can just write H plus squared. That way you don't need to worry about the anion concentration. Then you would divide that by HA. Okay, now you could do a little bit of algebra to rearrange this equation so that you can solve for just H plus. So if you move the HA over to this side and take the square root of it, you would get that H plus is equal to the square root of your Ka value times the molarity of your solution, which is HA. Square root all that. So then you can just plug in your numbers and you can find that H plus is equal to the square root of Ka, which is 7.5 e to the negative 3 times 0.45. And if you do the math, you should get H plus equal to 5.8 e to the negative 2. You can then take that H plus from here and plug it in over here. And then you could do pH equals a negative log, substitute in your H plus, 5.8 e to the minus 2, and then you would get that the pH, if you do the math right, hopefully I did, you get a pH is equal to 1.2. And that's how you would solve a problem like this. Okay?